Hey guys, this is volume day 5, and today we're going to add rate of flow to our volume problems. Okay, at the top of your notes, make sure that you've reviewed your length, area, and volume. So you should be writing centimeter, and then for area, centimeters squared, and for volume, centimeters cubed. Write the area and the volume formulas, please. All right, let's get right into it. Number 1 says a rectangular tank measures 80 centimeters by 50 centimeters by 60 centimeters. It is filled with water to its brim. If the water is drained out at a rate of 12 liters per minute, how long will it take to empty the tank? Okay, let's go ahead and highlight our question here. How long will it take to empty the tank? So what we need to do to figure out this problem is we need to find the volume first. Once we find the volume, we'll set up a conversion, and we'll be using that to figure out the rate, figure out the time it takes to empty the tank. So let's find the volume first. All right, we'll plug our numbers into our formula there. We have 80 times 60 times 50. If we multiply 80 times 60, we're going to get 4,800, and now we're going to multiply that by 50, and we're going to get 240,000. I'm sorry, I said that wrong. 240,000 centimeters cubed. All right. So since our rate is given as 12 liters per minute right here, we need to change that centimeters cubed to liters so that we're consistent. We can't work with centimeters cubed and then do a conversion with liters. That just doesn't work. Okay, so every minute 12 liters will leave the tank. So we need to empty 240 liters. So what we're going to do is we're going to set it up like this. This is why I've been having you practice unit conversions this way. So we have 240 liters to work with, right? And for every 1 minute, 12 liters are emptied. So we're going to set that up 1 minute per, my fraction bar can mean per, 12 liters. Our liters cancel out, and I'm left with 240 divided by 12. Which is going to equal 20 minutes. So my answer to this problem is just 20 minutes. Let's do another one together. An empty rectangular tank measures 60 centimeters by 50 centimeters by 56 centimeters. It is being filled with water flowing from a tap at a rate of 4 liters per minute. How long will it take to fill up the tank? Okay, now I'm wondering how long it's going to take to fill up, but basically this is still the same problem. We'll need to find our volume first, and then we'll need to set up a unit conversion to find how long it will take to fill up. So we'll plug in our numbers there, 60 times 56 times 50, and we're going to end up with 168,000 centimeters cubed. Since our rate up here is given in liters per minute, I need to change that 168,000 cubic centimeters to liters, so I'll divide that by 1,000, and there's my liter. Okay, now just a reminder of what's happening. For every 1 minute, 4 liters will go into the tank. We need to put in 168 liters. So let's set up that right here. So we've got 168 liters, 168 over 1 times 1 minute per 4 liters. We want the liters on the bottom because we want it to cancel out. Okay, so I'll cross cancel there, and I'm left with 168 divided by 4, and I get 42 minutes. Okay, why don't you go ahead and try number 3 on your own, and then come back and check your work. So go ahead and pause the video. Okay, let's do it together. All right, an empty rectangular tank is being filled with water flowing from a tap at a rate of 6 liters per minute. There's my rate. How long will it take to fill up? Let's find the volume first. 40 times 30 times 15. 40 times 30 is 1,200, and then times 15 is going to be 18,000 centimeters cubed. Since our rate is given in liters, again, we need to change that to liters by dividing by 1,000. So I have 18 liters, and then we'll set up our conversion here. We've got 18 liters over 1. We've got 1 minute per 6 liters. I know it's set up right because these cancel out, and I get 3 minutes. It will take 3 minutes to fill up that vessel. Okay, number 4 says 4 metal cubes of edge 5 centimeters are placed in an empty rectangular tank measuring 20 centimeters by 20 centimeters by 11 centimeters. The tank is then filled with water from a tap at a rate of 6 liters per minute. How long will it take to fill up the tank? Okay, so this time now we have some cubes taking up space in the tank. So we need to figure out what the volume of the tank is, the volume of the cubes are, and we need to subtract the volume of the cubes from the volume of the tank, and then we can do our rate and our not unit conversion, but we can just figure out with our rate by multiplying how long it will take to fill that tank up. So let's find the volume of the whole tank first. Substitute in our values, 20 times 20 times 11. 20 times 20 is going to be 400. 400 times 11 is 4,400 centimeters cubed. Now let's find the volume of our cubes. It says that our cubes are of edge 5 centimeters. So now I know I just need to multiply 5 times 5 times 5. And that comes from the length, the width, and the height all matching. They're all 5. And you know this answer because I gave you all of the cubes in your notes the other day. So the volume of one of those cubes is going to be 125 centimeters cubed. Now obviously we have to multiply that by 4, right? Because there are 400 of them. So when we multiply that by 4, we're going to get 500 centimeters cubed. Now I need to subtract the volume of the cubes from the volume of the tank because they're taking up space that water won't be able to take up in there. So when we subtract 500 from 4,400, we get 3,900 cubic centimeters. I need to divide by 1,000 and put that into liters because our rate up here is in liters per minute. We need those to match. So I have 3.9 liters is what the capacity of the tank is with those cubes in there. And for every 1 minute, 6 liters will go into the tank. We need to put in 3.9 liters. So let's set that up. We have 3.9 liters times 1 minute per 6 liters. Those cross cancel. And I have 3.9 divided by 6. So my answer is going to be 0.065, but let's go ahead and let's review how to do that division since we're working with the decimal right here. Now, when we do division of decimals, what we really care about is that our divisor is a whole number. Since it already is, we don't really need to do anything with the decimal. We don't need to move it anywhere. Okay, so we'll still start with a 3 and we'll ask ourselves, can we divide 3 by 6? Well, no. So the answer right there is 0. Right? So we'll go to the next digit and we look at those together. Can I divide 39 by 6? Yes, I can. 39 divided by 6 is 6. So I'll put a 6 above the 9. And 6 times 6 is 36. So I do my long division like normal. 9 minus 6 is 3. I'll bring down the 0. And now I have 30 divided by 6. And that will be 5. So that's how I get my 0.65 minutes. Okay, here is a list of the perfect cubes again. You should try those from memory before copying these down. So I'm going back. On the last part of your page, go ahead and write down all the cubes that you can remember, and then check your work. All right, go ahead and check them. Hopefully you're working on memorizing these. Like I said before, your life will be easy if you memorize them. All right, that's all for today. I hope that you have a great afternoon.